Hello, everyone. Alfred Cromwell here, founder and president of City Tutoring. It's getting rather late. It's almost evening here in Lynchburg, Virginia. And I decided to make this video because I was tutoring a student this morning at City Tutoring, and he was really having a hard time. Not so much with, he loves mathematics. It wasn't so much that he was having a hard time with mathematics, he was having a hard time understanding his reality that he has been cheated at his local school for such a long time. He is one of the many honors students who come to me. I take all kinds of students, by the way. In fact, some of my favorite students are the ones who are not honors because it takes a special kind of challenge to deal with those kinds of students. I also have students who come in from sometimes they are doing a workshop and come from we used to have a program, City Tutoring, with the local prison population because we wanted to bring mathematical thinking, mathematical rigor to people who are currently serving, young people in particular, who are currently serving time. Because I am a firm believer that when you have the right kind of thinking and you also have the right spirituality, of course, you can become a better person. And one of the most rewarding experiences for me has been working with students who have a dark past, who have who have redeemed themselves and who want to become better people. So, but anyway, so I was thinking of a quote by the mathematician Eric Temple Bell. And Eric Temple Bell once said, any impatient student of mathematics or science or engineering. Notice how he distinguished between mathematicians, scientists, and engineers. Very interesting. But he said, any impatient student of mathematics who is irked by having algebraic symbolism thrust upon him should try to get along without it for a week. And that really brings me to the topic of this video, which is I am actually going to share with you a review of functions. You really need to know your functions, especially by the time you get to Algebra 2. If you do not have a clear knowledge of functions by the time you get into Algebra 2, you're in big trouble, sir or madam. And I'm here to help you. I want to change your thinking so that you become, because one of the reasons I did a functions review with him is because the student wants to take Algebra 2. And I said, well, the first thing we're going to have to start with is a fundamental review of functions. Let's see if you really know your functions. Of course, he didn't. If you try to navigate the labyrinth of quantitative thought without algebra, without a solid algebraic foundation, you will quickly find yourself in a thicket of confusion. You will be armed with nothing but fingers and frustration. Yet, alas, we have students they are blessed. They consider themselves to be blessed. They're not really, but they consider themselves to be blessed with calculators. But they are cursed with impatience. They grumble at the sight of a simple variable, as though it were a medieval, I don't know, some of the faces my students put up in class, you would think that I'm using some kind of medieval torturing device on them. Once upon a time, I remember X, right? Solve for X would summon wonder or fear in some people, but now it only evokes dread. And where manipulation once meant the elegant dance of symbols, and now we see a frantic Google search or a plea to ChatGPT. You know, if I were in a, I should never, I'm a firm believer that a human being should not ever use foul language. But ChatGPT is one of those things that if I weren't blessed with the presence of the Holy Spirit and the Spirit of God that should dwell within a Christian, my human temptation would be to just use the most awful words to describe people who try to cheat their way using ChatGPT. I mean, just the thought of it right now, my instinct is to just punch them out. But no, that's not a proper attitude. That is not an appropriate attitude to take. But even worse than this whole ChatGPT or Googling answers is the modern classroom also is too often presided over by well-meaning, but I consider them to be lukewarm souls, if they even have a soul. They're really educational imposters in the strongest sense of the word. And they dispense techniques, formulas like aspirin, hoping to dull the pain rather than awaken the mind. They are not mathematicians. They are curators of worksheets. They are trained perhaps to soothe rather than to challenge. And these instructional pacifiers fear the unknown as much as their students do. They are terrified of the unknown. They are also very much afraid of their students. And hence we have the noble art of symbolic manipulation, and it's reduced to a sequence of mechanical push buttons and acronym-laden cheat codes. Use PEMDAS, FOIL. And the result? We have a generation who can graph a line on Desmos with flair, perhaps, but they quail at the sight of a factorable trinomial. Some of you don't even know what a perfect square trinomial is, and you're in Algebra II, or Algebra 1, doesn't matter. Some of you are even in calculus, and you don't even know what it is. There are students here at the local community college. I've tutored them. They come to me. They want help in calculus. When I use the term a perfect square trinomial, they look at me as if though I were an alien from outer space. Now, that's not their fault. I'm not blaming the students. An instructor should never blame a student for their ignorance. But you have to ask yourself, who was educating these people? Those are the people who are responsible for the failure of education in this country. And so we find ourselves in the present malaise. You have students with diplomas in hand, and yet they are algebraically illiterate, even when enrolled in a math class. We have young people who can text, perhaps. Many of them don't even spell properly in the text, but that's another story. But they cannot isolate a variable without spiritual anguish. They have been fed, listen to me, young people, if you're watching this channel, you have been fed all your life a steady diet of academic applesauce. It's pre-digested, sweetened, and devoid of any intellectual fiber. They lied to you, and they made you a failure today. But you can easily overcome that with the proper attitude. But what once was required discipline, reflection, and reverence, it has been replaced with colorful apps, cartoon avatars that chirp praise for, oh, congratulations, you've completed a multiple choice quiz. How challenging. So hard. Eeny, meeny, miny, mo. It's mathematics reduced to a marketing scheme, where rigor is seen as elitism and precision is oppression. There are people who seriously think that. But mathematics, real mathematics, is not a consumer product. It is a craft. It's a discipline. It's a language that demands fluency. True education begins when the student is no longer shielded from struggle. If you are not struggling, you are not being educated. You have to be taught to wrestle with abstraction and to find clarity through form. I don't teach you shortcuts here at City Tutoring. Those of you who know me from City Tutoring, you know that. That's absolute nonsense. What I teach you is structure. You learn, you derive, you prove. Not because it has real world applications. It does. But that's not my concern, but because it builds in you a mind that reasons rather than feels, rather than feels. And that's why I use the Dolciani approach. That's why I use the Dolciani textbooks. But there's a lot happening. And I'm going to share with you all the problems that we did. And if you're not familiar with functions, by the way, if you're going to struggle with these questions, you shouldn't be in Algebra 2. You should be demoted to Algebra 1. Nothing wrong with that. But we need to stop calling people honors. Are you listening, teachers? School administrators? That goes for you, Lynchburg, too. We need to stop calling people honor students if they're not actually at the honors level. All right, so on the first question that you see here, the student actually did normal. He did rather well. No problems here. This is the typical question you would find on a basic introduction to functions, right? If you have to compute them. So this one says find f of 2. That just means evaluate the function at f of 2. So he did f of 2 equals, and then wherever you see the x, you substitute it with the 2. So you have 2 times 2 squared minus 3. You follow the order of operations. 2 squared is 4. So now you have f of 2 equals 2 squared is 4. 2 times 4 is 8 minus 3. F of 2 equals 5. No problem. Then in the second one, the student evaluated the t. So it said, okay, f of t equals 47. So therefore, we have f of t. We substitute t wherever you see x. That's 2. And then t squared minus 3 equals 47. And then we have f of t equals 2t squared. And then if you move the minus 3 to the other side, you get equals 50. And we can divide by 2 now on both sides. And we get t squared is equal to this 25. But because we're exponentiating, you want to do the inverse operations. If you are dealing with equations, you take the square root of both sides to get rid of this. And now you have the square root of 25 is 5. So t equals plus or minus 5. So far, so good. Then in the third one, the student also solved it correctly. Find f of 3x plus 1. So what happens here is that every time you see the expression with an x, you're going to substitute that with wherever you see x. So that's 2 times 3x plus 1 squared minus 3. And we have to follow what's in the parentheses first, right? As per the order of operations. So this 3x plus 1 squared is going to give you 9x squared plus 6x plus 1. So you have 2 times 9x squared plus 6x plus 1 minus 3. And if you follow the order of operations, you have 18x squared, right? This is distribution, plus 12x. Sorry about that. I should erase. It looks sloppy. 2 times 1 is 2. Minus 3. And so now you have, for this one, 18x squared plus 12x minus 1. So that was no problem. However, when it comes to question number 2, the student immediately starts to run into some difficulty, particularly in the second part of the question. So in the first part, where it says evaluate g of 3, negative 5, negative 1, notice it says a function can be defined to accept multiple inputs. So if we use 3, -5, and -1 for A, B, and C, we have 3 times 3 minus 2 times -5 plus 7 times -1 squared. 3 times 3 is 9. This 2 times -5 is -10, but you have a negation symbol, so it's a plus 10, and then plus 7, because -1 squared is positive. So you have 9 plus 10 plus 7. And if you have 9 plus 10 plus 7, well, you have a function here, right? That looks very much like you would when you're dealing with the order of operations, right? And that equals to 26. The student, though, starts to run into trouble in part B. This is where things get a little complicated for him, because it says find B if G of B to -1 equals 21. So first, what the student does is says, he looked at me and said, that's easy. We're going to do 3a, right? So that's 3 times 2. And he noticed he did, because there's a b there already, so he actually just plugged in the 2. So now we have 3 times 2 minus 2b. And then we have plus 7 times -1 squared. And then from there, we're going to get from that -2b plus 13. -2b plus 13. So then the student told me, we need to find the value, since it's equal to 21, we need to find the value of b, so that -2b plus 13 equals 21. And if we solve here for b, we get b is equal to -4. And then the student thought that he solved the answer that way. But don't you see the mistake, everybody? Where is the mistake here? Well, let's check. If I said originally that I wanted you to find b, 2, and -1, you would now have -4, 2, -1. And if you do that, if we were to plug in those values, you then have 3 times -4 minus 2 times 2 plus 7 times -1 squared. And we're going to say that that's going to be that's going to give you immediately, that's actually going to give you, well, that's -12 minus 4 plus 7, which is going to give you -9. Do you see the problem? We wanted to get 21. So this is a bad solution. The student set A as 2 and C as -1, but left B as B. But that's not what you do when you are evaluating a function for the given values. When you evaluate a function that accepts multiple inputs, you have to make sure that you assign the values to the dummy variables in the correct order. So you have to replace the A in the function with B, and that's okay. And you replace B with 2, and you replace C with -1. So going back to the original problem, let's go back to the drawing board here. We now have 3 times b minus 2 times 2 plus 7 times negative 1 squared. And that's going to give you 3b plus 3. And we want it to be 21. So now that's going to give us b equals 6, as we desired. So be careful, young people, when you are using substitution. You have to go in the order, and it's okay to substitute a variable with another variable. All right, what about the third problem here? It says, suppose t of x is equal to ax to the fourth plus bx squared plus x plus 5, and we're saying that a and b are constants. We want to find t of 4 if they give us that t of negative 4 is equal to 3. Well, the student also had a problem in answering this question. He said he had never been exposed to a question like this in his Algebra II class. So let's use the tools that we know we can evaluate. We want to find t of 4, right? If t of negative 4 equals 3. Well, t of 4 would be as follows. We're going to first write an equation in terms of a and b, and then express t of 4 in terms of a and b, so that we can find t of 4, right? So this will give us t of 4 is equal to 256a, and we then substitute it for x squared, so that's going to give you 16b, and then you have plus 4 plus 5, which is going to give you 9. So now you have 256a plus 16b plus 9. That's a trinomial, by the way. So that means that they gave us in the problem, if you can find a and b, then you can evaluate the t of 4. So the other part of the information we have here is that t of negative 4 is equal to 3. So if t of negative 4 is equal to 3, we already know that 256a plus 16b, we already know the value of that. We know that that's equal to 2, right? So, however, unfortunately, that doesn't tell us a or b. But if we look back at your expression here for t of 4, you can see you don't actually need a and b, right? You need to have the 256a plus 16b. We already know that that is equal to 2. So you have an expression, 256a plus 16b plus 9. 2 plus 9 is 11. So you have to really keep your eye on the ball. You don't need to evaluate every single variable in a problem to solve the problem, right? Think about it, right? How did we know that t of negative 4 is 3, but we already had the 256a plus 16b minus 4, however, plus 5. That's how I got the plus 1 that I was describing earlier. So just be careful here. All right, the next one, we're going to find the domain and the range of each of the following functions. Well, let's have a look at the first one. The first one, the student said the domain and the range are all real numbers, right? So that's okay, because you can input any real number here so that the domain is going to give you, of course, all real numbers. And every time we plug one in, we get an output here that is also a real number. So that shows you that you can say all real numbers for both domain and range. So f of x here equals 2x minus 3. And you want to solve for x so that 2x minus 3 equals y. So for any real number here, we can let x, if we solve for x, is x equals y plus 3 over 2. And if you input anything in there, you have f of x equals y. So that's going to tell you that every real number is in the range. So the student didn't have a problem with this one. However, immediately started having problems with part B. F of x is equal to the square root of negative 2x plus 7. Well, the square root, remember this everybody, excuse me, the square root of a negative number is not a real number. We've said that many times at City Tutoring. So that means you have to have negative 2x plus 7 has to be greater than or equal to 0. And if that's the case, then your x value here, if you solve the inequality, it has to be, we're going to add 7 on, subtract 7 rather, on both sides. So you have negative 2x equals negative 7. So that's, you have to flip the inequality, remember? So you have x is less than or equal to 7 halves. And so the domain is going to be all real numbers less than or equal to 7 halves. And remember, when you're using interval notation, it's going to go from negative infinity to 7 halves. And this time on this side, I'm going to use a bracket. Why? Because it includes 7 halves. And you use open parentheses when it goes on and on and on, but you use the brackets when it ends at that point, we say. You can also you can guess here that excuse me, that negative 2x plus 7 has to equal any non-negative number. So the range here is going to be all non-negative real numbers. And how would you solve that or show that explicitly using algebra? So just like we did earlier in part A, we're going to set it equal to y. That means y is equal to f of x, and f of x is equal to the square root of negative 2x plus 7. You then would have to solve the equation for x. We say solving for x in terms of y. Actually, let's do that, just because I want to show you on the board, in case you're not used to these kind of manipulations. So for the range, we're going to say y is equal to f of x which is equal to the square root of negative 2x plus 7. So if we want to solve this for x in terms of y, you have to square both sides. And if you square both sides, you get y squared is equal to negative 2x plus 7. We got rid of the radical symbol there. And now you can solve for x. You can subtract 7 on both sides and then divide by negative 2. So you have x is equal to 7 minus y squared. And we must divide that by 2. So that means that for any real numbers here, for any non-negative value of y, you have to let it equal to this. So you have f of 7 minus y squared over 2. Sorry about the mess. I didn't want to be switching from the board to this. But I actually might have to. I need more room. So because we have a fraction here, so actually let me go to the board because I'm going to need more room. All right, so hopefully you can see now. This is the breakdown. F of x is equal to f evaluated for 7 minus y squared over 2. And then, of course, you take this, you go back to the original expression and you plug this 7 minus y squared over 2 where you see x, right? Because you're evaluating at that point. So now you have negative 2 under the square root symbol, under the radical symbol, times 7 minus y squared over 2 plus 7. These negative 2's here become, well, they become negative 1. So now you have negative 7 plus y squared because of the distribution axiom plus 7. The negative 7 plus the 7 cancel, and you are left with the square root of y squared, which of course is equal to y. So the final step here, that square root of y squared equals y, now that is only valid because y is not a negative number. You can see that all non-negative real numbers are in the range here. Because remember, for every non-negative value of y, you can find an x value such that when you evaluate the function, you get y. So since it cannot be negative, there are no negative numbers in the range of f. So we say that the range is all non-negative real numbers. And you can write that as brackets 0, since it includes 0. And you can go all the way from there to infinity, but of course that's an open parentheses. Make sure you get into the habit of using interval notation and set notation, at least in my classes. Now the last question that you see, the third question was 2t over t minus 1. Right, let's go have a look at that. All right, so we have the g of t equals 2t over t minus 1. First, we have to find the domain here. Well, we know that um, you cannot have 0 in the denominator. So t cannot be equal to 1, right? Because it's illegal to divide by 0 in mathematics. There are no other restrictions, however, on the input to G. So you could say here that the domain is rather straightforward. It's all real numbers except 1. But when it comes to dealing with the range, that is a little trickier. Now, to find the range, let us allow y to be equal to g of t. So if we set it equal to y, we have y equals 2t over t minus 1. And from here, we got to solve for t in terms of y. Well, we have a fraction, so that means we can multiply both sides by t minus 1. If we multiply both sides by t minus 1, we get y t minus y equals 2t. And if we solve this equation, we can solve it for t in terms of y. And that would mean that t is equal to y over y minus 2. Now, in this case, any desired output for y, except that y cannot be equal to 2. And you can now use this equation. You can find the input, t, that we're going to plug in to g of t, that you want to produce the desired output. So if we want to see that 2 is definitely not in the range of g, note what happens when you try to solve for g of t equals 2. You then have 2t over t minus 1 equals 2. And if we try to solve this, you multiply both sides of the equation by t minus 1. So now you have 2t equals 2t minus 2. But that has no solution. So what's going on here? The range is all real numbers except 2, and you can label that when you say all real numbers except 2, once again, you can use interval notation. So that means that you could say negative infinity to 2. Now, because we're not including 2, we have to use a parentheses, right? So if we do, all right, and then also includes 2. Remember, if we use the union symbol, and this, again, parentheses means not including that, but it goes to positive infinity. So it's an open interval in that sense. Notice the u here, right? Remember that the u it means or in math. So y is an element of this, right? Y is in the interval that I just showed you here. It could be negative infinity to 2, or it could be in the interval 2 to infinity. Remember, the union of two intervals, when we say that, it means that it consists of all numbers that are either one or both of the intervals. So we just saw an example here where we use u to label a union of two intervals. Now, when it comes to intersection, that means that our numbers that are in both of the intervals. And we use that upside down U if you would have seen my videos on the introduction to logic part. Now, if you're dealing with numbers that are either in the interval, in one interval or another, or both from one interval, then you have the union symbol. And we also have a special notation when it comes to when you have all real numbers except a few specific values. You can usually write it as all real numbers except, let's say, 2. And we usually use a forward slash. So like something like, let's say, if it doesn't include 2 in the set. That's fairly standard. And if you wish to exclude specific variables or values, you just list them inside the curly braces. So you would still say, like, let's say you can't use 5, 6, and 7. You would say are 5, 6, and 7. Right? That means you cannot use those. All right. Now let's look at part D. Now for part D, 9x squared plus 4 to find the domain and the range. Well, notice here you can input any real number here. So we can say immediately for 9x squared plus 4, the domain of H is all real numbers. But we have a square here, right? So it's in the real numbers, but because, remember, the square of a real number is always non-negative. So that means 9x squared is always non-negative. And the expression, therefore, must be greater than or equal to 4. And since 9x squared plus 4 can equal any number that is greater than or equal to 4, we would say that the range here is 4 to infinity. And of course, open parentheses, but since we include the 4 as part of it, it has a bracket. So notice that earlier, when we found the domain, we considered operations that we are not able to perform. So as we know, you cannot take the square root of a negative number in a real function, and you cannot divide by 0. So that is typically how you find the domain when it is not obvious, as you saw just now and in a little bit earlier in part A, that the domain is all real numbers. So finding the range is also often a matter of considering the possible outputs of special expressions when you have square roots, perfect squares, or absolute values. But as we saw earlier in part C, the restrictions on the range can also be a little bit more subtle. And so you have to find a strategy that is useful when you want to determine the range of complicated functions. And how do you do that? Well, you can often find the range by setting the function, when you have the function definition, equal to a new variable. And then when you solve for the what we call the dummy variable in terms of the new variable will be of great assistance to you. And sometimes functions are defined with explicit constraints on the domain of the function itself. And when you're dealing with the range of such a function, it really includes or consists of only of those outputs that can be obtained from the permitted inputs, right? So an example that you have is the one I put for the student. Look at this one. 2 radical x plus 3, but p of x is only defined for 4 is less than or equal to x is less than or equal to 9. So we want to find, according to this problem, we want to find the range of p. One of the biggest mistakes students make with this is that they say, okay, the output of the square root of x can be any non-negative real numbers. So the result of this expression can be any non-negative real number greater than or equal to 3. But if you do that, you're completely ignoring the restriction on the domain of P. You have to take into account, and I'm warning you, you have to take into account any restrictions on the domain of a function when finding the range of the function. And notice in this problem, P is only defined for the inputs here being x, such that 4 is less than or equal to x, and that is less than or equal to 9. So the range has to consist of all values of P that can result from inputting a value of x that will satisfy this condition, this restriction. And because you have in this problem 4 is less than or equal to x, which is less than or equal to 9, we have 2 is less than or equal to x, which is less than or equal to 3, right? By dividing. If we multiply all parts of this is called an inequality chain, by the way. If you multiply that, you actually get 4 is less than or equal to 2 radical x. So and that 2 a radical x is going to be less than or equal to 6. And now, if you add 3 to all parts of this chain, you then have 4 plus 3 is 7. So you have 7 is less than or equal to 2 radical x. And then that has to be equal to plus 3 is less than or equal to 9. I hope that makes sense to you all. So that means that all, because basically here now all x such that we have this inequality chain, we have 7 is less than or equal to p of x, which is less than or equal to 9. But we're not finished. I haven't finished yet. You've All I've done here is show that all values in the range of p are going to be between 7 and 9 inclusive. But we haven't shown that all real numbers from 7 to 9 are in the range, have we? And this is something, well, or at least somewhat obvious, because p of x goes smoothly from 7 to 9 in the same way that x goes from 4 to 9. But in order for us to prove that all possible values, excuse me, from all possible values from 7 to 9 are in the range, we have to let y equal this function. And then you always solve for x in terms of y. So then that means we have x is equal to y minus 3 over 2 squared. Which means that for any value of y that goes from 7 to 9, you can actually use this equation so that you want to find the value of x so that this equals y. And you have to make sure you see why all the resulting values of x are in the domain of p. So finding the domain and range when you have more complicated functions can be pretty, well, slightly tricky. But it's something that you want to practice. Let me show you a couple more problems. I'm not going to solve them because I don't have time, but at the moment. But here are two final problems, or three final problems, and let's see how you do on those. So I hope this video is helpful to you. If it was, I ask you to please continue to support this channel. Please continue to help us grow. It is amazing the growth we are having and the message, the attitude of mind that we are fostering for math. Thank you all.